Okay, so we're going to be talking about the doubly linked list this time, which is similar to the singly linked list with now two ways out. But to get to know why we have to do this, let's talk about delete from tail and see how this works. Because delete from tail is one of the motivations why the doubly linked list is interesting. So let's say we have this list, but we have, let's say, 3 elements in that list. This is a singly linked list. Now let's say we have 5, 7, 2, and this is pointing to this one pointing to this, the head points here and the tail points here. Now what happens if I delete from tail? What should happen? I'm sorry? The tail will change to the one before. But how do I get the information of the one before? Can I just say go before? No, I can't. That's the problem. There's no way back. There's always a way forward, but there's no way back. So how can I know now? Because what I would like to do, I would like to get this here and put it in the tail, so I can make the tail point to this one now. But to do that, there's no way to go from the tail. I need to go from the head and keep going until I find the tail. No, until I find the one before the tail. And that's the issue. Now how do I do that? I need to start here and then check if the next of the next is going to be the tail. So if I say this one next, this one next, is it the tail? Yes, oh, it's the tail. That means, okay, I know that the next is going to be my new tail. So if the next is the tail and I'm deleting, then I need to just check the next to make it the tail. So what I'd like to do, start here and ask the question, is this going to be the tail? The next of the next is the actual tail. If it is, then okay, now move out and put it here. So after I put it here, I can remove this one because I just put the tail to be the one before the last, and then this one is easy because the next should be now null instead of being pointing to somewhere, which makes me delete from the tail. A question? Well, of course we need to make it a loop, and I'm just showing you with 3 elements. Now I don't know exactly how many elements there are. So imagine I have 100. Now I need to go in a loop trying to look for this one before the last, one before the tail. And let's have a look at now this is what does this do? That's one singly linked list. It's just one way. Yeah, so that's the problem. So now let's have a look at this, how it works. Now let me just do this cancel. So I just would like to see how, if we have this kind of situation, let's now have a look at how this works. Is it empty? No, it's not. So let's move on. Now I get the tail.info is stored into this EL. So this is the tail.info. Why is it kept here? Why do you need to store this? Well, because I'm returning it. Because this, when it deletes, it gives you the value of what was deleted. So you can, I don't know, if you want to delete from it, you can just use it if you want to. If you don't, you just discard it. So now if it's empty, we do nothing. Just there's nothing to delete. But if it's not, I'm going to take the tail and store it here, and then I'm going to see, is the tail and the head the same? Which means they're pointing to just one node. I have only one node. If I have only one node, then the head is going to be the tail, it's going to be null, and I have nothing else to do, just return that, and that's it. So if there's only one, okay, just make the head and the head and the tail be null, because that one is going to be deleted now. Return it, and you're done. Now the fun. Now what if we have more than one? So now we fall here. So what does this do? So I have a temp. This is my temp. Maybe I should just put it in different colors. Would be more convenient. Let's put it in blue. So this is temp. Now what am I putting in temp? Yes. Yeah, it's just a variable name. Name it whatever you want. A, B, C. It's just temp for temporary. But it's just a name of a variable. If you don't like it, it's confusing. Just name it whatever you want. You don't like it. Let's call it A. Or I don't know, old. Whatever you want. But it's just a name of a variable. So now this temp will put it in a loop. And notice now this loop does not have nothing inside, doesn't have anything inside. It's just a loop with a semicolon, which means once this is true, it doesn't do anything, just okay, keep moving. But the advantage of this is just it's going to keep moving until it finds the one before the last. Let's see how this works. Now I'm saying temp in this for is going to be initialized to the head, so it's going to be here. Then I'm going to ask, is temp.next different than the tail? It is. So there's nothing to do. So it's like I'm going inside, but there's nothing inside. So I just go and go to the next. Now if I go to the next, which means this temp, this is the incrementation. The temp is going to become the temp.next. So what is the temp.next? Temp.next is this one. So temp now is going to be temp.next. And then I go back, I ask, if the temp.next is the temp.next different than the tail? No. Temp, this is temp. .next, this is one. Is it different from the tail? This one is the tail. So it's not. So the loop will stop. And then my temp is going to be pointing at the one before the tail. Did you get it? Do we need to put maybe more in the notes? Let's put more. It just cancel everything and start with more than just 3, so it will make more sense. Okay, so these are 1, 2, 3, 4, and I'm filling it 5. So 1, 2, 3, 4, and 5. So anyways, these are just so this is pointing, each one is pointing to the next until the last one, which is pointing to nothing, which is empty. This is the head that points to the first one, and the tail that points to the last one. And let's get our blue temp. So I have this temp now. It starts here, and let's do it again. So maybe can I get it here? Just would like to show them all. Let's just hide those, and I can do it like this. Okay, so the first thing I put the head temp points to the head. That's where we are. And I ask a question: is temp.next different from the tail? Temp.next, this is the temp.next. Is it different from the tail? Yes. Are you with me, right? Is there anything? Yes, there was something, but I just want you to postpone that to once I finish. So temp.next, is it different from the tail? Yes, it is, because the tail points here and we're here. So temp.next is different from the tail, so I'm going to get inside, but there's nothing to do. I increment. Temp is going to become temp.next. This is temp.next. So temp is going to be moved to point here. Then I go back to the question again. Is temp.next different from the tail? Temp.next is this. Is it different from the tail? Yes. So get inside, but there's nothing to do. Then increment. Temp will become temp.next. Okay, what is temp.next? This is temp.next. So then temp will become temp.next. And then I keep moving. I ask the question, is temp.next, this one, is it different from the tail? Yes, it is, because this is the tail. So I'm going to again get inside, but there's nothing to do, and increment the temp to become the temp.next. So now temp points to this one. And now the fun starts. Is temp.next different from the tail? No, because temp.next is this, and it's not different from the tail. So I stop. I get out of the loop, and then let's see what's happened next. The tail is going to be what's in the temp and tail, which means now I'm changing the tail, sorry, and it should be the same, pointing at the same place that the temp does. So this is going to be pointing here. And what I do next is the tail.next. Now this is the tail. .next is this one. I don't want it to be pointing to here, so I remove this and make it null. And that's how I delete from the tail. So it's this loop now. Imagine that I have 1000 elements. So I need to start from the first one until the last one to be able to delete the last one. And that's the problem. That's why it's kind of convenient if we can have a way just to go from the tail, just go back and delete the one that is the tail. That's the motivation, one of the motivations of the doubly linked list. However, advantage again, disadvantage. The advantage, I can now delete easily from the back, from the tail. But I need to, every time I add something, now instead of having an element that only has next, I will have next and then previous. Now the idea is that now, okay, I cannot go back more than what I did. Okay, can I start from scratch? New, don't save. So okay, and now the idea is that, you know what, I'm going to have an element value, and then I'm going to add two things. Next and previous, along with the info. So let's say I'm going to add 1, 2, 3. How this works is that I have this element who has 3 parts: the information, the next, and the previous. Yes.
Can we add home also?
Can we add the what?
Home.
Home? What do you mean home?
Like in the presentation, the PowerPoint, let's have the next and before and home.
Home? I don't know. Let's talk about this. Then later on, when we reach that stage, we'll talk about it. Okay? But for now, we don't need any home because the head is the home. When you say home, it's maybe the first one that you mean.
Yeah,
that's the head.
Yeah,
That's the head. We always have it. We're not going to be removing the head and tail. We're going to keep those. But what we did, we just, as compared to the singly linked list, we just added another piece of information in the node that is going to capture what's before. Is it too cold? Just switch it off if it's cold. Yes.
What will happen if you delete the semicolon?
In the semicolon? Oh, then you have a problem because this is going to be considering this to be inside of the 4. So it's going to change your temp. So it's going to change your tail, which makes now your tail is going to change with the temp, and this condition is not going to be false one day, because I mean it's always true, because the temp and the tail.next is not going, they're not going to be equal. And the problem is also, there's another problem, is that one day temp.next is going to be null, and I'm going to try to take this null, go to the next of the null and put it in temp, so it's going to raise an exception. So this semicolon is really important, even though it doesn't do anything. But for us, what's interesting is to go to the one before the last. So now, if we have a doubly linked list, things are going to change in terms of how I add, how I delete, how I do things. But let's see how much of the change is needed. Now I still have the head and I have the tail, and the beginning head and tail are null, fine. But when I add a new one, it's going to be the same thing, the head and the tail. But the next is null, the previous is null.
So 2 directions.
Because of two directions. Now if I add a new one, I'm going to, let's say I'm adding to the tail. So what is going to happen? This number 2 is to the tail. So what should happen when I add a new one? The tail should point to the new one. This is what we used to do anyways. Singly or doubly, it doesn't matter. But now, this next is going to point here. We've been doing this anyways. Now the new thing is, we need to do, is this one point here. So instead of this null, well, this is still null
Yeah. And
because it points to nowhere, and this one is null because there's no next. But this points to the one before, and the one before points to the new one. So I have these things to do. Now let's just do one thing. I don't need this anymore for now. And I'd like to put these two things side by side, because I'd like to show how I add to the head. Maybe go to the navigation and find add to tail. That's what we were talking about. So okay, I was already there, and let's come back here and see the add to tail. Now this time with a doubly linked list. Now look at this thing. First of all, maybe let's compare the nodes itself. Now this is the doubly linked list, this is the singly linked list. Now the only difference, as you can see, is that I have next and previous. And also, now I have a new constructor that takes not only one, but two, the next and previous. Sorry, those one that has two now has three. But the rest is the same, except that now I'm initializing another variable, the previous. Before it was only one, which is the next. Now I have the next and previous. And basically, you know what, I'm going to do this, because it's the same, but this time it's just 3 instead of 2, and I think it would have been better. So it's basically the same thing. Just instead of 2, I'm having 3 now parameters, because I have info, next, and previous. Before I had this info and next. So this constructor, if you call this one, put everything to be null. If you call this one, you give me an element, let's say the value. Before I just initialized with the value, and then the next was null. Now if you just give me the value, the next and the previous are going to be null. But if you give me all the values, I'm going to use them. Now instead of 2, I have 3. So that's the difference. The second thing is add to the tail. Let's go to this one, add to the tail, and see how these two compare. Now this is, now I'm going to ask if it's empty. Well, basically, you know what, I just would like to change this a little bit. So this is not empty. Now how do I know that this is not empty? Well, I can just do the same. I don't know why this was slightly different, but anyways, this is going to work the same way. So if this is not empty, that's what I'm going to do. I'm going to create this new node, that this time just with the elements. When I do this, the next is going to be null, right? Now this one, I create a new one with null for the next. But this one, I don't want it to be null, because now there are two things that happens here. And let me bring this back. Let's go back, cancel, cancel, cancel. Now this is, okay, hold on. This is how it is. This one is created, but I don't want to create it with this to be null. That's fine. I want this to be null. There's nothing next. But the previous, I don't want it to be null. It should be pointing to the same place that the tail is pointing at, right? So that's why in this, the first step from this line 39 is to generate this object. So to instantiate this object. When I prepare this object, what I'm putting, this element el, this 2, the next to be null, and the previous to be pointing at the same place that the tail is pointing at. So this is the first part. The second part is to move the tail to this new one, which is, this is what this does. Now this takes this, instead of pointing it here, it points here. What needs to be done now is that this one should be pointing here instead of this one should be not. So the head, or as it was done, is the tail dot previous dot next. But before that, I'm just going to show you just why they did this. I'm going to just make something like this. The head dot next is going to be the tail. The head dot next, which means this one, should be pointing to the tail. This is my tail, right? Now my new tail is pointing here, so this one should be pointing here. So that's what I do. So this will work only with the first when I have only two. But if I have three, that's a problem. Because now let's see what happens if I add another one. If I add another one, same thing will happen. It says add to the tail. This is 3. The first time I'm here, I'm going to put null into the next and the tail into the previous, which means this one is going to point to the same place the tail is pointing at. Then, now look at this. The head.next is going to be the tail. Head.next is here. This is the one. Is going to be pointing to the tail? No, I don't want this. What I want now is the head.next.next point to the tail. So that's why let's do it the other way around. Instead of having it starting from the head, then let's go from the tail. So now what I says, first of all, when I did this, the tail was moved to here, because I created this with this info pointing to the same to the tail. Then once I store this tail here, I can change the tail to be the new node that I just added, which is this end of this second part of this line here. This first one does this part, does this link here. The second one, when I put this into the tail, now the tail has changed. Instead of being here, it's now pointing to this new one that I just added. Now once I have this, in order to get this link here to be pointing to the tail, so you see the tail is going to be somewhere. So I'm going from here. This is the tail. I go to the previous one, and in the previous one, the next one should be the same as the tail, and that's why I'm going to this dot previous dot next should be the tail, and that's the twist. Why this is needed is that if I'm keep adding this, I cannot start from the head and do the next. I have the same problem that I had before with the one single linked list. Now with this tail dot previous dot next, I'm using this double linked list to my advantage. So in order to get this linked correctly, I start from the tail, go to the previous, and say the next of that previous should be the tail, and this is what this does. Is that okay? A lot of fun, right? Yes, yes. The order is important. If you swap the order, it's not going to work. So that's how this now add to tail works. We just need now to work with the previous and the next. Before, how we were doing that, because there was no previous, we just kept adding, and we changed this by doing tail.next to be the new node. We just added immediately to the new node. The way we were working was different, and then we just remember the new tail. Now it's a different way. We just go to the tail, go to the previous from the tail, and the next we updated with the new tail that was there. Okay, so that's the idea behind that, and that's the motivation. Let's just go back now to the slides. I don't know, you were talking about some home. I'm not sure what that was, but let's have a look at this. Okay, and well, we spoke about the motivation, what deletes from the tail, etc. So this head, now every node has two parts, the next and previous, And what are the disadvantages of this? So the advantages, I can go in both ways. From the head until the tail, or from the tail until the head. I can move in all directions. The disadvantage though is speed. What do you mean speed?
No, not speed.
Memory. Well, there's a small increase in the memory, because now instead of having like two pieces of information, the information and then the next, I'm having 3 now. So I increased by 50% the memory that I'm using for every node. So one of the disadvantages. The other one is more coding, more complexity in the code. So it's more complex. The code is not as straightforward as it was before. Now I have the next and previous to update both of them. So I need to work with 2 things now instead of just one. So that's yeah. So anyways, that's the idea. I don't know if I skipped something that I can be talking about. These are, we can just check if it's empty by doing this. Clear, put everything to null, and get the first. Well, we get it. If you would like to get the last, also, you know, this get first, get last. We did some get first before, as in the lab. And where is it? I may not have stored it. I don't remember. Oh no, this is because this is our code. This is my. No, this is not. Anyways, I'm looking for the code that we added, and it seems that I don't know where I put it. I thought it was this one. Didn't we solve it together? But we called it singly linked list. Where was it? Oh, this one. Yeah. Now I did this with the not without these generics. But what am I looking for? I think I'm just confusing, and now we did it with some student thing. Are we missing something?
This one we changed it to double. This is double.
Yeah, but there was something. I think this. I'm missing something. Anyways, that doesn't matter. I think there's something. I'm confusing something, or maybe I left out some file somewhere. But anyway, that's the code. Anyway, I'm not going to look into all that unless we would like to have a look at. Now let's just maybe have an idea about some of. Now we've been deleting from the tail. Now what happens if we delete from the head? Now if we compare the two, it's look the same for most of the parts. So if it's null, well of course you return null, then you get the head or info, alaikum salam. And then if they are equal, then you just make them head and tail. Else, normally this is what we did, head equal head.next. But now the only new thing that I have to do is to update the previous of the head, because when I delete from the head, this one should be gone, which means this should not be pointing to here. So this previous should be null. There's nothing because I deleted from the head. So what was there before is going to be removed. So these are some minor updates sometimes, but some of them need more work, and but it's basically not that complicated. See, there's not a big difference. Print all is basically the same because we need to start from the first until the last, so we don't even need to use this previous. So we pretty much use this previous mainly on this delete from tail. Yes.
So the head, if we want to delete, the head will be the name, and the tail, if we want to delete, the tail will be the block.
Will be what?
The
previous.
previous.
Yes. Yes. Okay, so that's the main idea. Now, what would like to be doing is to have a look at some of those linked lists, because these linked lists are already available that I can use them. And let me just create a new project that I'm going to call cs241 now, because I need to week 2 linked list. Just no need for that, just linked list. Week 2 linked list. Why am I doing this? Because okay, I don't need this anymore, and maybe later. I'd like to show you that there is something called linked lists, and maybe it's because it's a generic. Basically, let me just make it an integer. New linked list, and by the way, I can initialize it without putting also integer again there. I know that maybe there's some, I remember I saw sometimes that there's a difference, but putting it here or not doesn't make any difference for whatever we use. I remember there was some, it makes some kind of difference. I don't remember now what, or maybe I'm mistaken, I'm getting confused. But this is okay, I can just do something like this. But what I would like to show is that this list, or maybe you know what, I can just click here, this linked list, to get with the NetBeans. You can just press on the control key and then you click on it, it will take you to the file. Now this linked list takes you and extends whatever and implements a lot of things, but what we're interested in is the node. And let's have an idea about this node, and look at this. So its implementation of this linked list is a doubly linked list, because there's a next and there's a previous. So that's what I'm trying. I wanted you to have a look at. Or maybe we can just have a look at other things. What if I'd like to what is available? Now look at all these methods that are available here. If I'd like to add, probably where does it add? If we look at this add, it says link last, which means probably it adds links E as last element. So it adds to the tail. And let's try to make sure that we understand this, how this works. But notice what they do. You have this, they increment, and they increment this, which is kind of weird. So if they link to the last, what this is going to do is going to create a new node L to put the last in it. So what they do, they just remember the last one. This is the last for them. This last for them is our tail. So they take this tail and put it into this L that they call last, L for last. And then they create this new node based on the information that we just created. This is a new node E, but what are they doing is something interesting. What is this? Because they put this into the constructor. You see, this constructor of the node, the first element is the previous. Then they have the element, the value, and then the next. Why are they doing this? Because they are representing it not like this, but let me show you if I can. They represent it like this. So every element is going to be like this, and this is another element. So if I add 1 and 2, for example, this is going to be null, this is going to be pointing to here, this is going to be pointing to here, and this is going to be null. So that's why they represent that in a way that when they initialize the previous, the value, and then the next. But at the end of the day, it doesn't matter. The way you represent it is the same thing. But I want you to understand what was happening. Now let's go back to where we were, and it was about add, or what they call it, linked last. So we added, when we add, it took us to linked last. So what does linked last do? It creates a new node with the previous to be the tail, our last, and then with the value, and the next is empty. And once this new node is created, it's put into the last. And if this is null, that means the last is null. That's the first one as well. But if it's not, the next of the last that was, remember, this is the previous last. The next of the previous last is put as the new one. It's the same thing, but it's done differently. I don't know, it's a bit maybe confusing the way I explained it. But the size plus plus, what I'm understanding from this is that they're doing it every time they add an element. So if you ask them, I mean, if you'd like to get the size, they just print the size. So let's see if they would like to, how do I get the size, or how many elements or something like that, or count this size here. See, the size looks like just like a getter that gives you how many elements in the list. So every time you add something, the size is going to be incremented. Every time they delete, let's say we remove first, let's say, every time they delete, now this is going to do this, whatever, throw some new, and then unlink first element. If we go to here, there's going to be a size minus somewhere. Why they're doing this way? Maybe because they don't want to, once they would like to calculate the size, to start calculating it. Especially if you have a big list, it will just take some time. So they preferred using more memory and to have the calculation of the size done incrementally as the items are added, as compared to don't do this calculation and then when we want it, just calculate from the beginning until the end, go from the first one to the last one and count how many there are. Honestly, it's a implementation decision. It has advantages and disadvantages. So they're using more RAM, which is not that much of the RAM that they're using. It's just one variable extra that you have to do. But you need to be careful not to forget to increase or decrease every time you add or delete from the node, from that list. Yes.
So the size are not doing what I call it.
Yes.
It is doing that.
When you add, exactly. When you add, remove,
the size are changing.
the size changes. Yes.
That's when
Exactly.
start to calculate.
Not like what we did.
In the program.
Not like we did. Did you do some count somewhere? I remember we did some count somewhere. And which is exactly basically the same thing as this print all. If you remember, we copied from print all, and then we just we count. Yeah, I remember maybe we did it in this double. No, I did not, because we changed something. So maybe we did it in. I remember we did this thing with the student. No, maybe I was doing it on my computer. Now I'm confused because I'm missing something that I cannot find. But anyways, what do you mean? No, I think the item this was given. We changed it to student. I remember we did something with the student, right?
Yes.
But then I cannot find it. That's why I'm confused. Probably I did it on my computer. I was just remote desktoping to my computer, and now it's on my file. I think so, because, and this is a good sign that I'm getting old, because I cannot even remember what happened last week. Anyways, that's life. So let's go back and continue. So what I'm trying to say is that you don't have to implement this from and looking for it from scratch, because it exists already. You can use this linked list to add that. And linked list is an implementation of a doubly linked list. And there are a lot of different kinds of methods that are available there. And also there's you can use it the same way that you were using. I mean, the other one that you were using, the singly linked list or the doubly linked list. Just add, remove. add to head, and so on. And the array list, this is also available in java.utils, is another implementation, but this time with an array. Now this is also available. We've seen that, I mean, sometime in Java 2, if you remember. The array list is a very convenient implementation, but it's still, this is an array. It just keeps everything in an array. So it has the advantages and disadvantages of the array. So do you remember what are the advantages of an array? You know the position quickly, easily. And also it's an easy implementation. In terms of the coding of an array, it's much easier than having to work with this next and previous and stuff. So that's the advantage. The disadvantage? No. You cannot insert in the middle easily, and you cannot add to the head easily as well. Because if you add to the head in an array, you have to move a lot of values to make space for the first one to be empty to put a value in. So anyways, everything has an advantage, disadvantage. If you're trying to understand something and you cannot capture the advantage, disadvantage, you haven't understood it well enough. Okay, I think now I'm just going to stop here for this. There's not much thing to do because I want to go for the practice and start with the lab. So let's stop the video here.